So hi everybody, I'm Ellie. To give you a little bit of a background on me and maybe why I decided to work on this project. I studied mathematics in school, just pure math. Really enjoyed it, and then ended up working at King's as soon as I graduated. So I've been at King's now for a couple months doing software and also helping Topaz doing outreach coordinator stuff. So I get the best of both worlds, and I get to show you what I've built on presentations like this. So really excited to show you today. Before we jump in to all of you deploying your own jobs, I'm just going to walk you through the 4 steps of DCP and how it works, just to make sure everybody's on the same page. And then this is a simple example, so when we get to a little bit more of a complicated example, hopefully everybody follows along and understands how it's all working. So we have distributed computing in 4 steps. So our first step, we want to talk about our key store and our workers. So like Dan said, all of you today will be a worker. And if you were here last week, we talked about how you have your own compute group. Okay, so we'll go to the Kathmandu compute group, and then you'll put in that special password. And you don't have to worry about it right now. I'll send it in the chat when it's necessary, but just so you get the idea, that's how you'll become a worker on your compute group, is following to that link and putting in that password. And then obviously, if you're deploying a job, you do have to pay for the job. But if you're being a worker, you can also get paid for doing other people's work. So what we're going to do today is do a little bit of a cycle. And so you're going to deploy a job, but you're also going to work on jobs. And so we're going to use that same address so that DCP knows it's you who's doing the work, but also knows it's you who is deploying the work. And so we get a little bit of this cycle going where all your money is being regenerated. And then, so to the actual DCP part, we have our input set. So in this case, this is our lowercase to uppercase example. So in this very simple example, our input set is the string that we want to convert from lowercase to uppercase. And Dan mentioned slices. So in this case, our slices become each letter of the string that we're converting. So each one of these letters will be sent to a different worker to be converted. And then we have our work functions. Remember, we have our input set and our work function. The work function is what we're applying to our input set. So obviously in this case, our work function is the to uppercase, right? Converting our lowercase to uppercase. And then we have our compute.for, which is the whole heart of DCP, right? So we tell it, here's our input set, which is our string. We tell it, here's our work function, which will convert it to the uppercase. And then in our case, because we want to use a compute group, we just add that one extra line there. And we give it our key, which will be Kathmandu, and we'll give it our join secret. So that's not necessary. You can do it on the public scheduler, but today we're going to do it on the compute group. And then we await our results. So we just wait for the workers to do the work. It all gets sent out to different computers, your phone, anything that can do work, and it will come back to us. So this is sort of what it looks like, right? We have our input set, compute.for, all the slices going to different workers. And then when we get it back, we wait, and we get our nice result back in all caps. So that's it very simply. Before we try it ourselves, does anybody have any questions on that? I know Dan also just asked for questions, but any questions before we move on? I'm going to go with, no, I'm just going to move you guys over here so I can keep an eye on the chat. But so today we're going to be doing something a little bit more interesting than to uppercase. We are going to be working with the Mandelbrot set. So some of you might have heard of this before, but essentially the Mandelbrot set is just a very special set of complex numbers. And it became really popular because you get these really pretty fractal images. And you can find a lot of videos online. If you just do a quick search for like Mandelbrot zoom, you'll get a lot of these videos where they'll do these infinite zoom-ins into these fractals. And it's really beautiful. They have really pretty colors. Sometimes they put music to it. So after this, I would really recommend looking up those videos because they're like mesmerizing. So like we said, DCP, you send out a job, right? So our job today will be creating this GIF of a zoom. So we're going to create our own Mandelbrot zoom and a GIF. And our slices today, so our smaller parts of our problem to be executed in parallel, will be a specified number of frames of that zoom. So does that make sense to everybody? And let me know if I'm going too quickly or too slowly, if I'm being boring, just let me know.
Only question, do you want people to follow along on the notebook, or will you send it at some point, just so?
I was going to send it at some point. Okay, I can share it now, though.
No, up to you. I just want to make
Okay, I was just going to go through this, and then I was going to share it. So I'm just going to go a little bit further into what the Mandelbrot set is. So like I said, it's a special set of complex numbers, C, for which the following function here, so this z squared plus c, does not diverge when iterated from z equals 0. Now, I know the first time I heard that, I was a little bit like, I have to wrap my head around this. So we'll go through a couple examples. But essentially, what we see with this function is either our value will get really large and go off towards infinity, or the value stays bounded by 2. So if we look at an example of both of these cases, first we'll look at c equals 1. So what we do, we have this function, right, z squared plus c, and we're starting where we're iterating from z equals 0. Okay, so we plug in 0 for z, and then our c is 1, and we get the answer of 1, obviously. And then what we do is we take our previous answer and we plug it in for z. Okay, so then we get 1 squared plus 1 equals 2, plug the 2 in, we get 5, plug the 5 in, we get 26. And for c equals 1, this will keep growing and growing and growing. So obviously this is going to get arbitrarily large, it'll go up towards infinity. And so this is not in the Mandelbrot set. C equals 1 is not a complex number that is in the Mandelbrot set. But if we look at something like c equals negative 1, you can see we're bouncing back and forth from this negative 1 to 0, negative 1 to 0. And that'll continue to happen, negative 1, 0. And so this will never go up past 2. It'll never blow up past, go up towards infinity, right? So c equals negative 1 is in the Mandelbrot set. Okay, do we have any questions about how that works or anything like that? I don't see anything, okay. So I'm just gonna give you an overview of how we're actually gonna code this, right? Because how do we go from this function into making these really pretty pictures? So essentially what we want to do is we want to establish a canvas. So we're going to say our canvas is going to be y by x, right? And then we're going to say for every single point in the canvas, we're going to pass it through that function, okay? And we're going to iterate through that function, and we're going to keep track of how many iterations it goes through. And then once we hit a maximum number of iterations, right, because we want to have a maximum number in case we get this c equals negative 1, which would keep going forever. So we iterate through until we hit a maximum number of iterations, and we say, did it go up towards infinity, or did it never go past 2? And depending on which category it falls into, we'll color it a different color. Okay, so we'll color that one point on that canvas a different color. So that's high-level overview. I do want to show you a bit of the code of how this works, and I can go through it quickly if you're not super interested in this, but essentially, this calculate escape time is the core of us making our Mandelbrot set. This is what's doing the iterations through the function and saying, is it going to go up to infinity or is it not? And it's going to return k, so it's going to return how many iterations we did. So that's how we're going to color our points, right? This is where the criteria comes in for coloring our points. Now, these two functions here help with us creating our actual coordinates, right? Our actual axes. Because we're looking at a canvas, and our canvas might be 600 by 400. That's what it is today. We're going to do a 600 by 400 canvas. But our Mandelbrot set is plotted on the real axes and then the imaginary axes, right? So our x is real, our y is imaginary. And so we have to sort of translate these points on the canvas into points on our real and complex plane, right? So that's what these two functions do. They'll take a point on the real canvas and then they'll plot it onto our real and imaginary axes. And then we have our make frame function, and this is the other really, really important function. And what this function does is it sets up an array where each point in the canvas will have a spot in the array. We'll actually have 3 spots in the array for the color, right? Because we have red, green, blue. And what it'll do is we're going to calculate our complex coordinates, right? So that taking point on the canvas and putting it onto our real and imaginary axes, it'll calculate that. It'll calculate our escape time. So that's how many iterations we're going through that function. And then what it'll do is it'll take that escape time that we came up with, that maximum number of iterations, and it'll plug it into our escape time to color function. And that'll tell us, based off of how many iterations you did, what color are we going to make this? And then we'll keep doing that for every single point on the canvas, right? So that's what I was talking about before. We also want to have the option where instead of sending maybe 1 frame to each worker, we want to send 3 frames to the worker, right? And so the way we do that is by giving it the first set of complex coordinates. So in our case, it would be -2 to 1, -1 to 1. And then we want to give it the last set of complex coordinates. And when I say last, I mean the last one of the complex coordinates we want to make in between, if that makes sense. So we'll have our first one, we'll have our last one, and then we'll tell the worker, I want to make 3 canvases in between, right? So this function will come up with those complex coordinates for those in-between frames. This again is just helping us come up with those in-between frames. We have our escape time to color. So you can see here, I'm passing it the current escape time, so how many iterations it did. And then just depending on how many iterations it did, we have all these fun functions that change the color. And then we have our zoom in function, right? Because the whole idea is we want to have this really pretty zoom into all these fractals and images. So what this does is it takes our complex coordinates and it takes a point that we want to zoom towards. So there are a lot of interesting points in the Mandelbrot set to zoom towards. I just picked one today. But so Z0 is the point we're zooming towards. And then we have the speed at which we're zooming towards. And so that's honestly the gist of how all of this is going to work. Nothing too out there or too crazy. And so now all of you get to do this with me. Do we have any questions just about the explanation of the Mandelbrot set and how this will work before we get into actually deploying the job? Or any questions about how DCP works, how this will work on DCP, anything like that? If not, I just sent the link to that collab, right? So we're going to do everything in a collab today, which just makes it really nice for your setup. You don't have to worry about complications with installing different libraries and DCP and making sure you have the right version of everything. It just takes care of everything. So if you all want to open that collab up, and then all you'll need today is this collab and then 4 files I'm going to send you. So we talked about the key store, right? We talked about how we need a key store in order to deploy jobs, in order to make money off of doing work for other people. And so the first thing I'm going to send you is default key store. And the only thing you really have to make sure of is that you keep it named default.keystore. And then the other thing I'm going to send you are the 3 code files. And so all we're going to do with the collab is upload our 3 code files. So let me see if I can send all 4 at once. I don't think it wants me to send files over Google Meets.
We can do it over Discord, Ali.
Yeah, that's what I was just going to say. What is the best channel for me to put it on Discord?
You can keep that in DCP chat. So
DCP chat there. Okay, perfect. Thank you. So if all of you could open up the Discord and go to DCP chat, I've added all 4 files. So the first one should be your default key store. And like I said, you just have to make sure all of these are named the same way, especially default key store. Then you have the image animation file, you have the main file, and you have the Mandelbrot set file. So I'll give you guys a few minutes just to make sure you have all of those downloaded. And essentially, yeah, you saw the Mandelbrot JS file. That was the one that I just showed you. We have the image animation file, which essentially just takes our array colors, and it will translate that into a PNG file, and then translate those PNG files into a GIF. And then we have our main function, which will take that will be our input set, our work function, and our results. That's what that's doing, the main DCP work. So I'll give you guys a little bit more time, and just make sure you're saving those files somewhere where you'll remember where they are. I have mine saved in a special Mandelbrot folder. You're welcome to keep it in downloads. But if that's all set up, the other thing I want to set up is our worker, right? Because we said we want to have our worker being sent to a specific payment address, so we're making our money back. So if everybody, when they're ready, could go to dcp.work/Kathmandu, which I just sent in the chat, and it's going to immediately prompt you for a join secret. So I will send you that as well. And this is so that only you guys can work on your compute group, right? We don't want just anybody with access to it. So we put that join secret on it so that only people who have that secret can work on it. So if I could maybe just get like a hands up if people are ready to keep going. I don't want to keep going if you guys are still downloading stuff. Okay, I see a few hands. Okay, perfect. Okay, awesome. So if everybody has this, the DCP web worker open, all you're going to have to do is I'm going to copy that payment address for you, right? Because we want that specific payment address. So I'm just going to copy that as well into the chat. Okay, we're going to go to our web worker. We're going to hit this gear here. We're going to go to our settings. We're going to erase the payment address that's there, and we're going to paste in the one that I just sent. And then all you have to do is hit save changes. Okay, so I'll just give you a couple minutes. Let me know if you have any issues with this, and please feel free to just interrupt me. You can unmute, you can send something in the chat. If I don't see it right away, I'm sure somebody else from Kings will unmute and let me know what's going on. So if everybody's set with that, then we're just going to hit start. Okay, so now our worker, it says no work available, but our worker's actively looking for work to do, right? It's going and talking to the scheduler and saying, hey, is there any work that I can do right now? And right now the scheduler is saying, nope, nothing going on yet. That's fine. Okay, so we're going to open up our Colab again. And we're going to scroll down to this configured Node.js and DCP environment. Okay, and we're just going to hit play on the first cell. And you might get this warning. And it's just saying this notebook was authored by someone, one of our colleagues. You just say run anyways. It's all good. Nothing's wrong. And this part will take the longest. It normally takes 30 seconds to a minute, but all this is doing is essentially saying we're using a Google Colab and we want to use Node.js, right? We want to use JavaScript, we want to use Node, all this stuff. So all it's doing is setting up Node, setting up our NPM, and allowing us to access DCP. So that's what this is. Like I said, it just takes a little bit of time. If you run into any issues, let me know. But yeah, this is what's so great about a collab is, sometimes everybody runs into trouble with what versions of things they have and accessing everything. But with a collab, it's all right here, easy to run. And once that's done, just make sure you always get that green check mark because there are some things that are sensitive to when you run it. We're going to hit DCP install. We're going to run that. And obviously, this is allowing us to run DCP on this collab. So super straightforward, one line. Yeah, super easy in the collab. And again, any issues, just feel free to speak up. And then this part is important that we get right, okay? Because this is when we're uploading our key store, and it needs to be that default key store. I know I'm like a broken record, I keep saying that, but it's super important. So when we hit play, you're going to see this choose files at the bottom. We're going to click on that. All your files should show up. I'm going to go to Ellie. I'm going to go to my Mandelbrot, my Colab, And then that's where I kept my default key store. But wherever you kept it, that's where you're going to go and you're going to upload it. And you should see saving default key store to default key store. Is anybody having any troubles with this so far? Or if I could even get a raise of hands if everybody's on the same page as me. Awesome. Okay, great. So then let's just keep going. The next part is uploading our libraries. So like I said, we want to take our arrays of those colors and we want to convert them to PNGs, and then we want to convert them into a GIF. So that's what these libraries do. Sharp allows us to convert it to a PNG, and then PNG file stream and GIF encoder allow us to make those PNG files into a GIF. So we're just going to upload those. If you needed anything else, any other libraries, you can see how simple it is. Just an npm.install and then the name of your library. So super straightforward. This one shouldn't take too long. And then this part's also important. So now we're going to upload our files. Those 3 files I sent you, the main, the Mandelbrot set, and the image animation. This is where we're going to upload them. So you're going to hit play. Again, you're going to see that choose files. I have my Mandelbrot set file open, and I'm going to upload all 3 at the same time. And again, we want to pay attention here. Make sure it's saying image animation is saved to image animation, right? We don't want the naming to be any different. So that shouldn't take too long. I'll give you guys another second. And then we'll move on to our require statements. So this is just telling us we need these files. Should be really quick. And then this part is where we're setting up stuff for our Mandelbrot set. So we see here we want to have 10 frames, but that each worker is going to get 2 slices. It's going to get 2 frames. Or sorry, not 2 slices, but it'll get 2 frames. We have our canvas size. So like I said, we have our 400 by 600 frame. This could be changed. And then here we have our Z0, which is the point we're zooming towards. Again, it could be changed. There are so many different interesting points. You Google cool Mandelbrot zoom points and a bunch will come up. We have the speed at which we want to zoom towards. And again, this was just a speed that I thought made the GIF look nice. And then we have our maximum number of iterations. So how many times we want to go through that function before we call it quits. So all of these can be changed, and you'll just run that, and it should be relatively quick. And then we have our input set. So our input set in this case is those complex coordinates, right? So our first complex coordinates would be -2 to 1, -1 to 1. And then, right, our code would continue to calculate the new complex coordinates. But that's our input set. And then here we have the actual DCP part. So this is the exciting part. So when we hit play, we should all have our web workers started, right? We want that running so that someone can pick up the work. But we're going to run our DCP function. Now, like Dan mentioned, some of you may run into troubles. That's okay. Just let one of us know. There are a bunch of us here to help. But what you should see is all of these new ready states. And what we're looking for is job accepted by scheduler. That's what we want to see next. So here we go. There we are. Job accepted by scheduler, waiting for results. We have our job ID. Now we can go over and look at our web workers, and you can see my web workers already started to pick up slices, right? So it's doing the work. And I have no work available. I'm assuming that some of you guys are picking up my work right now, right? Because this could go to any worker anywhere in the world. Doesn't matter. If you're set up on your compute group, it'll go to anybody. So you can see I got a slice 10 back. Still waiting.
I see Levi has raised his hand. Is that for a question, Levi?
No, I think I forgot to put it down.
Oh, good.
So you can see I'm getting all these slices back. There you go. Dan has 6 slices. Awesome. And I think I have all mine back. We're just waiting for it to finish up and send the results back. Should be finishing up. There we go. So that was relatively quick, right? We have this pretty computationally expensive program, right? We're going through all of these iterations of this function trying to calculate these values. And for us, this took, I don't know, 30 seconds to a minute. It's pretty crazy, right? So now the next function is just taking our results, which are those arrays of those colors, and it's saying make them a PNG and then make it a GIF. Awesome. Yeah, you guys are all receiving slices. That's great. Yeah, so you can see, let's see if I have any right now. I don't have any right now. I think you guys are sucking up all the work, which is good. So I ran that, and then we get our output. So you can see it's in the middle of a zoom, but it'll zoom back out, and there's our Mandelbrot set. So let me know if you guys get it. I would love for you guys to share your screen if you do get it, but also let us know if you run into any problems. And what you can also see, if you go over to your file system on the left, and you go to Mandelbrot images, you can see the GIF, but you can also see every single image it produced, which is really cool. So if we wanted to, we could look at our most zoomed point. Let's open that up. We can see it on the side here. We see that's what it looks like at its most zoomed for us, which is really awesome. So yeah, let me know if any of you got it. Please feel free to share your screen and kick me off. But until then, I'll just keep showing you my pretty GIF. But like I said, any of these values can be changed. So afterwards, if you guys have the code, you have the collab, like you're all set to play with this as much as you want. So you could add more frames so that your zoom gets deeper, which would be really cool. You can change the size of your canvas. You can change the point you're zooming towards. Like I said, just Google interesting points to zoom towards for the Mandelbrot set, and you'll get a bunch of options, and they'll show you what it will look like when you get really close to it. So all of this can be changed, and you guys have everything you need to play with this. The other thing you can do is I showed you, where is it? I showed you how I made my color scheme, but you're welcome to open up this Mandelbrot Set.js file, play around with it, try to get different colors. If pink and blue aren't really your favorites, then by all means, you can make it green, orange, whatever you wanted just by changing that palette. So has anybody else finished up?